This reaction, it looks a little bit different, but the one thing I want to do is I want to balance this thing in a base. If I take a look at my charges, my oxidation states, it's pretty easy to do the chromium ones. I've got hydroxide. I've got 3 hydroxides, each at a -1, so that means the chromium is a +3. The CrO4 2-, each oxygen's a -2, that's a -8, has to equal a -2, and so therefore the chromium's a +6, right? And so I can see that the chromium's changing oxidation states, but the question is, what else is changing oxidation states? And if we take a look at the other reactant, we have H2O2, and if you take a look at the Lewis structure of this molecule, and I think we did this earlier when we were looking at oxidation states, the hydrogen, if we say that the oxygen is a -2, that would mean that the hydrogen would have to be a +2. And the hydrogen cannot be a +2 because it only has 1 proton. And so the hydrogen here is a +1, making the oxygen a -1. And so we have oxygen going from -1 to oxygen a -2. So now we know the two things changing oxidation states. One's an oxidation reaction and one's a reduction reaction. Let me start with the easier one, the chromium one. And so here we have chromium hydroxide, and that's going to go to chromium or chromate ion here, right? So again, the chromiums are balanced, so that's good. The next thing is to balance the oxygens, and we can do that with a water molecule. So now I've got 4 oxygens on the left and 4 oxygens on the right, and then to balance the hydrogens. So I've got 2 hydrogens with the water and 3 hydrogens with the hydroxide, so that's a total of 5 hydrogens. Now I did say that we were going to balance this in a base, but the secret behind balancing a redox reaction in base is to treat it just like an acid, and we'll fix it at the end. All right. So that's most of that reaction. The thing that we haven't done yet is to balance the charge, and so the left-hand side has no charge. The right-hand side has a +3, -2, +5. So if we add 3 electrons in here, we can see that we've got an oxidation reaction going on. The other half reaction is H2O2 going to what? All right, and so remember what I said earlier is that first you balance every element other than oxygen and hydrogen. That's done. And then the next thing you can do is balance the oxygens with water. And so that's what I'm going to do here. I'm going to balance it with 2 waters, because that way I can get 2 oxygens on each side. Lastly then is to balance the hydrogens. I've got 2 hydrogens on the left, 4 hydrogens on the right, so I'm going to add 2 hydrogens. And so what is wrong here is my charges aren't balanced, right? And so I'm going to need 2 electrons added to the most positive side, right? So 2 electrons plus 2H+. And this actually agrees, surprisingly, with the charges up above. So the chromium went from +3 to +6, so that's a 3 electron transfer, and so that's what we see there. The oxygen went from -1 to -2, that's a 1 electron transfer, and that's really what we see down in our reaction below. It says 2 electrons, but it's 2 electrons because we're changing the oxidation state of 2 oxygen atoms. So each oxygen is going from a -1 to a -2, and so that's why we have 2 electrons. So now we see that our electrons are not balanced on each side, so I'm going to take this top reaction and we're going to multiply that by 2, and the bottom reaction we're going to multiply by 3, and that's going to give me 2 waters plus 3 chromium hydroxides plus 6 electrons plus 6 protons plus 3 H2O2. And that's going to go to 2 chromates plus 2 times 5 is 10 protons plus 2 times 3 is 6 electrons plus 3 times 2 is 6 waters. And again, we can cancel out like terms. Again, the electrons must cancel out, so that's good. We've got 6 protons on one side, 10 protons on the other, so we're going to take out that 10, We'll put a 4 in for that. And waters. We've got 2 waters here. We're going to take out that 6 and make that a 4. So my overall reaction now says 3CrOH3 plus 3H2O2. Why do I have, sorry, I should have 2 chromium hydroxides. 2 chromium hydroxides. Chromium hydroxide, H2O2 products, 2 chromates, and 4 H pluses, and 4 waters. Alright, so if this is a balanced chemical equation, 2 chromiums, let's count total oxygens on the left. I've got 2 times 3 is 6, plus 2 times 3 is 6, so I've got 12 oxygens on the left. I've got 2 times 4 is 8, plus another 4 is 12 oxygens. Hydrogens, I've got 2 times 3 is 6 hydrogens, plus another 6 hydrogens is 12 hydrogens on the left, and 4 plus 8 is 12 hydrogens. And so all my elements are balanced. Do my charges balance? I've got neutral on the left-hand side, and on the right-hand side I have 2 times the negative 2 is a negative 4, plus 4 times 1 is plus 4, and so negative 4 plus 4 is 0. So it's neutral on the left, neutral on the right. I have a balanced chemical equation. The problem here is that it says plus 4H plus. So let me go to the next page here real quick and see if I can reproduce that reaction. 2CrOH3 plus 3H2O2 is going to give me 2CrO4 2 minus and 4H plus and 4 waters. Alright, so we said we were going to balance this in a base. The way we're going to make it a base is by adding base to the left and the right hand side. And if I want to neutralize those 4 H pluses, I can do that by adding 4 hydroxides to the right hand side. In order to keep it balanced, I have to add 4 hydroxides to the left hand side. Right? And so my overall reaction now reads, but the one thing I want to look at here is combining that H plus and OH minus. When you add strong acid to strong base, you get water. And so I've made 4 waters. So now my reaction says 2 chromium hydroxides. Whoops, that's a pretty bad structure. Let me try that again. 2 chromium hydroxides plus 3 H2O2s plus 4 hydroxides gives me 2 chromates plus 8 waters. And again, I should check this out and make sure that it continues to be balanced. One way in which I can balance that is to check just the charges of the left and the right. I've got 4 negatives right there, and actually I have 4 negatives right there. So my charge is balanced. I'm going to assume that all my other atoms balance as well.